Hello, data voyagers. I am Igor Alcantara, and I'm here to talk to you about something called the Simpson Paradox. But it's not that one. It is something else I would like to talk to you about. So, in a nutshell, a Simpson Paradox is when you have some trend in your data that initially tells you something. So usually when you analyze that data by one specific dimension or the total number of a particular variable, and that tells you something. But then when you analyze it against other variables together, then it tells you something different. And it's usually a trap. A lot of misunderstanding in data analytics comes of the people not understanding or not testing for Simpson paradox. We should always test for Simpson paradox. I'll give you an example, then I'll show you in Qlik how we can identify a Simpson paradox. So basically, imagine that you testing different cancer treatments, and there is basically two treatments you're testing: treatment A, treatment B. If you compare the effectiveness of the treatment, you realize that treatment A is better than treatment B because more patients under treatment A improved compared to patients under treatment B. However, when you analyze the same data against the type of tumor, then the result is the opposite. Then treatment B is better. How is that possible? So let's dive in. So let's jump to Qlik. Um, so not this, but this. Let me explain the data we have. Let's take a look at this data, and then we'll explore how this data is an example of a Simpson paradox. So this data is data from the California DDS, the Department of Driver Services, and it's basically money that was given, funded to specific people, specific citizens. And then this is basically, it's a sample of 1,000 people. This is the total funding, about $18 million. Per person, we have a median of about $7,000 funding. All right, seems good. Now let's take a look at this table here. Let me maximize this so we can have a better look. Looks at the total funding per ethnicity. So white nor Hispanic, like white people, they got way more money than like Hispanic or everybody else. Then you might say, well, that's misleading. It's maybe because there are more white people in California than everybody else. Well, let's take a look. So that's the population within, not in California, but within these 1,000 people sample. The difference, it's not that much. So look at this. The whites are 40% of the sample population, and the Hispanics is 38%, pretty close. However, the whites are 40% of the people, but they get 55% of the money. That's a big difference. The Hispanic, they represent 38% of the population, and they got 23% of the money. And even if you compare the average, so how much money on average each person got, whites, they got like close to 25,000. So less than half than that were given to Hispanics. And I'm only mentioning these two ethnicities because they correspond to the majority of the population in our sample. This is actually true data, is a sample of a true data, and the California DDS, was filed a lawsuit against it. So then, is that true? Well, let's take a look at this. Let's see what other data we have. So if we go to the selection tool, we have the age of the people. We have the age cohort, basically it's an age group, the ethnicity, the actual spending, the gender, and this is just an ID. Great. Let's see gender. let's see gender. Let's see the same data as, gender. So let me go edit, and I'll basically, we can do other type of charts. I'm just gonna do a table, or actually, we can make it quicker. I can copy this table. I can paste this table right here, and I'll simply replace ethnicity. So let me right click, delete that, add column, dimension. Let me get gender, move up, and there we go. Let's analyze it now. So females and males, they got um, pretty close population, and this percentage here, of course, will not work. But let's look at the amount because it was designed for the other one. But let's look at the amount. Very similar. So it's not so that same behavior we don't see in gender. Now, how about the actually? Let me remove this. How about the age group, which is another dimension we have that. So let me remove this. Let's add a dimension, and let's get the, we can do age cohort. And let's see now if we have any difference in here. So look at this. So we got like 22 to 50 and 51 and plus. We got the majority, but they also got majority of the population. But actually, look at this. 18 to 21, they got way less money, but they have way more people than 51 and plus, which it doesn't show bias. And if you're older, you need more funding for like adapt your car and other things like that. So maybe there is an explanation. Great. Now, this tells me something. There is one particular age group, at least, that got more funding disproportionately than everything else. Now, that tells me that I need to compare ethnicity with the age cohort. So let's do that then. I'll do something different. Instead of a table, I'll do something more fun. So let me do I like a box plot because it shows me, so let me drag a box plot here. I like a box plot because it shows me, let me remove the title, like the statistical distribution of the data. So I'm gonna add ethnicity as my dimension. Actually, I'm gonna add ethnicity later. I'm gonna add the ID first. So that's identifying each row. And then I'll add another dimension, the ethnicity. And my measure, I'll do the average funding. All right. And let me change a few things here. I want to focus on the distribution, not on the exception. So let me exclude the outliers. And I will show this horizontally. And let me expand this. So look at this. I like to focus on the median first. Look at the median. And if I come here, and just to make it simpler to analyze, let's then select just Hispanics and white people. So let's select Hispanic. And white people. There we go. So look at the median. So the median, and if I hover of whites, is like 15, almost 16,000. For Hispanics is way less, about 4,000. So it's less than half, which shows what we are observing. Now, I will do this. I'll take this and I'll add as a master item. I'll call this ethnicity box plot, edit, and I'll remove from here. Why I'm doing that? Because I want to analyze that by age group. So now let me go to custom objects, and I'll go to Qlik visualization bundle, and I'll find a trellis container. And so let's expand the trellis a little bit. All right, so my dimension that I want to analyze is age. Remember, we want to see that by age. And I want to add as my visualization the ethnicity. And then I can expand this, maximize it. Let's edit, let's remove edit sheet so we can see it. So look at this. Ages 0 to 5. I got Hispanics has a higher median, which is the opposite what we are observing. Look at 6 to 12. Hispanic, they have a higher median as well, which is different than what we experience in the totals. Now look at 13 to 17, pretty similar. To 18 to 21, pretty similar. 22 to 50, pretty similar. And 51 and plus, also above. So how is that possible? If I analyze that by age, Hispanics are either equals or higher than whites. But if I remove the age, is the opposite. So that is the Simpson paradox. So are we having a bias in favor of whites for funding? We are not. We are not. What's happening here is most of the fundings are going to older people. Most of the fundings are going to older people. And most of older people are whites. That's what's going on here. So look at the median for only that group. The median for whites is around 52,000, almost 53. For Hispanic is 54, almost 55. So Hispanics are a little bit higher, but not too much. But there are not a lot of Hispanics in that age group. So when you sum without the age, because 51 and plus are getting much more, way more money than whites get in general, way more money. But then looking with this perspective, then it shows there's no bias. It's just a behavior of a very specific population distribution. So that's the Simpson paradox. You always have to test against Simpson paradox before coming up to conclusions regarding specific bias in a population or in anything. Coming back to the cancer treatment, the treatment A, B that I mentioned is a real case that happened many years ago. It was basically that they were giving treatment A to less severe patients. They were given treatment B to more severe patients. Treatment B was more effective, but in the total, comparing just the type of treatment, treatment A showed seems to be more effective because most of the patient was less severe. So most of those patients recover, but almost all of the patients more severe that were treated with treatment A, they did not survive. Most of the patients, severe or not, treated with treatment B survived. But because of a very specific population distribution, when you analyze by just one dimension, it shows you one behavior. When you analyze it by that dimension and something else, which was the type of cancer or the severity of cancer, then it shows you the opposite. So that's the Simpson paradox. That's why it's called a paradox. So I hope this is useful. Always test for a Simpson paradox. Now, in conclusion, I'll ask you to, if you not yet, go to our YouTube channel, which is where you're watching this right now. Subscribe, activate the notifications so you always notify when we have new content. My colleague and friend Mark Hossa, he's posting some very interesting videos about like the whole development cycle in Qlik Sense and Cloud, which is pretty cool. And send us recommendations of videos, either AutoML, Qlik Answers, whatever you want to see. Automations will do it for you. And check our blog. So there's a QR code here on the screen. Let me see this side. No, wrong side. That side. There is a QR code there. Make sure you check out our blogs and find us, Data Voyagers, and us personally on LinkedIn. We're always posting stuff. Okay. I hope you enjoy and see you next time.